What assumptions are made in estimating that global lithium resources could be depleted within 65 years at an average annual growth rate of 5%, and what uncertainties or limitations exist in these projections? How do these resource limitations and cost challenges threaten the widespread implementation of lithium-ion technologies in energy storage systems and electric transportation? What alternatives to lithium-ion batteries are being explored to address issues of material scarcity, cost, and sustainability, and how promising are these alternatives in terms of performance and scalability? How do these challenges underscore the need for innovation in battery chemistry and energy storage system design, and what role does international cooperation play in solving these issues? What policies, technologies, or investments are needed to ensure that the transition to renewable energy and electrified transportation remains economically and environmentally sustainable? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What is sodium, and why is it significant that it is the fourth most abundant element on Earth? How widely is sodium distributed across the planet, and what does it mean when we say it has a seemingly unlimited distribution? What are sodium-containing precursors, and how large are their supplies globally and specifically within the United States? What is soda ash, and why is it important that 23 billion tons of it are located in the U.S.? What is trona, and how is it related to sodium carbonate production? What is the cost of trona per ton, and how does that compare to the cost of lithium carbonate? How does this cost difference influence the economic feasibility of using sodium instead of lithium in battery technologies? Why does the abundance and affordability of sodium provide a compelling reason to develop sodium-ion batteries, SIBs, as alternatives to lithium-ion batteries, LBs? Why is there a growing need for an alternative to lithium in large-scale battery applications, and how does that drive attention towards sodium-ion technology? When did research on SIBs begin, and how does that timeline relate to the early development of LIBs in the 1970s and 1980s? Why were SIBs initially studied, and what factors caused the research to be largely abandoned in favor of LIBs? What kind of advancements in lithium-ion technology overshadowed SIBs during that time, and how did the commercial success of LIBs contribute to this shift in focus? What were the technical limitations in the past that made it difficult to study or commercialize sodium-ion batteries, such as the quality of materials, electrolytes, or glove boxes? What challenges did researchers face in observing electrode performance in sodium-based cells, and how did those challenges hinder progress?